Welcome to qnawire.
So in this case, what we have is a 0.340 mole per liter solution of sodium fluoride. This means that the concentration of the fluoride ion is going to be equal to 0.340 molar. And we know that the Ka for HF is going to be equal to 7.2 times 10 to the minus 4. First of all, remember that Kw is equal to Ka times Kb for any acid and base that we're going to have in aqueous medium. So the value for the basicity constant is going to be equal to Kw divided by Ka. Remember that Kw is equal to 10 to the minus 14 divided by Ka 7.2 times 10 to the minus 4. The value for Kb in this case would be 1.389 times 10 to the minus 11. Kb corresponds to the reaction of F minus plus water that is going to generate OH minus plus HF. This is the inverse reaction of Ka essentially. So this corresponds to Kb. We're going to employ this value since we know that we have fluorine atoms in solution and we're going to have water added to it. So our ice table, well, rice table if you consider the reaction, everything is going to be written down in molarity. So of F minus, we start with a 0.34 molar solution. Water doesn't matter, we start with 0 and 0 of each of them. The amount of change is the amount that is going to react, corresponds to minus x. Over here, we're going to generate plus x, and at the equilibrium, we're going to get 0.34 minus x, and x. So, since we know that the value for Kb is very small, and this is equal to the concentration of OH minus times the concentration of HF divided by the concentration of F minus, what we can say is that we expect x to be very small. That means that 0.34 minus x will be approximately 0.34, my initial concentration. So the value for Kb, we're going to replace the concentrations that we got at the equilibrium. So instead of concentration of OH minus, we're going to put x. Concentration of HF, we're going to put x again, and the equilibrium would be 0.34 minus x. So we get x times x divided by 0.34 minus x. Now we're going to apply our approximation. So we get x squared divided by 0.34. And from here, solving for x, we get a square root of 0.34 times Kb. Recall that the value for Kb is equal to 1.389 times 10 to the minus 11. Using this, x is equal to 2.17 times 10 to the minus 6 molar. And this is equal to the concentration of OH minus that we have in solution. So what we can go ahead and do is calculate the value for pOH, which is minus the logarithm of concentration of OH minus, which gives us 5.663. Now, we know that pH plus pOH is equal to 14. Thus, the value for pH is going to be equal to 14 minus pOH, which is 14 minus 5.663, giving us 8.337. So this is going to be our final pH for the solution. So with that, it would be all. Thank you very much and have a good one.